Anthony Raj. He has pursued his bachelor's, master's and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Thiruvalluvar Arts and Science College and Idea Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series B.Arc Mathematics Semester 1 Lecture 7. In this lecture, we are going to see the contents of sphere, tangent plane to the sphere, plane section of a sphere. These are all the concepts we are going to see in this lecture. We know sphere is a three-dimensional solid body. The volume of a sphere can be obtained by a very basic formula like 4 by 3 pi r cube, where r is the radius of the sphere. That is in higher secondary level. In the analytical geometry, a sphere is represented by an equation. To obtain the equation of a sphere, some steps has to be followed. So, in that step, first we need to define the sphere. In the definition of sphere, the locus of a point is considered. The locus of a point which moves in space in such a way that whose distance from the fixed point in space is always same is called the sphere. So, the definition of the sphere says it is nothing but the locus of a point. This point moves in the space from a fixed point, then the movement of this point from the fixed point will be equidistant. If such equidistant is moved, then it will give a sphere. Then the fixed point is known as center of the sphere, and the distance of the variable point from the fixed point is known as radius of the sphere. This is how center of the sphere and radius of the sphere are defined in analytical geometry. So, we learnt the definition of a sphere and the definition of radius of the sphere and the definition of center of the sphere. Then in another way also the sphere can be defined. For that we need to take a circle. Then let the circle to rotate. The rotation of that circle traces a solid body. So, the surface generated by a circle when it rotates about its any diameter is also called a sphere. This is how you can define sphere in another way. Now, let us come to the equation of a sphere. To obtain the equation of a sphere, whose center and radius are given. Like that, if 3 points on the surface of the sphere are given, then again equation of the sphere can be obtained. Like that, in different ways equation of a sphere can be obtained. Here we are going to see the equation of a sphere whose center and radius are given. Let C be the center of the sphere, and coordinates of that center C is assumed as alpha, beta, gamma, and let r be the radius of the sphere. Let P be the any variable point on the surface of the sphere whose equation is to be determined. So, to determine the equation of the point, the following circle is imagined. In that circle, this is the center C and this is the point on the surface of the sphere. This point is P. Let Cp is equal to r, which is nothing but radius of the sphere. Then Cp square is equal to r square. That means both sides of this equation is squared. So, we got Cp square is equal to r square. Let us keep this as equation 1. Further, since Cp is the distance between 2 points, that is center point of the sphere and any point on the surface of the sphere. Since Tp is the distance between 2 points C, which has the coordinates alpha, beta, gamma, and P, which has the coordinates x, y, z. Then the distance Cp is equal to, by the distance formula, square root of x minus alpha the whole square plus y minus beta the whole square plus z minus gamma the whole square. So, this expression gives the distance between the center point of the sphere and any point on the surface of the sphere. Now, substitute this value of Cp in equation 1. Equation 1 is Cp square is equal to r square. After substitution, we get the expression x minus alpha the whole square plus y minus beta whole square plus z minus gamma the whole square is equal to r square. So, this is the required equation of a sphere when center of the sphere and radius are given. Here the center is alpha, beta, gamma and radius is r. So, we get the equation of the sphere like this. Then the next case is the equation of a sphere whose end points of a diameter are given. So, you can assume any diameter of the sphere. The end points of the diameter of the sphere are x1, y1, z1 and x2, y2, z2. Then the equation of the sphere is given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 is equal to 0 is the required equation of a sphere whose endpoints of a diameter are given. In this case, the center of the sphere is obtained by this expression, that is x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. This is how center of the sphere and equation of a sphere can be obtained when endpoints of a diameter are given. Now, general form of a sphere, general equation form of a sphere. To obtain the general equation of a sphere of radius r having center alpha, beta, gamma, we need to go to the equation of a sphere whose radius r and center is given as x minus alpha whole square plus y minus beta the whole square plus z minus gamma the whole square is equal to r square. If you expand this, we will get this expression, that is x square plus y square plus z square minus 2 alpha x minus 2 beta y minus 2 gamma z plus alpha square plus beta square plus gamma square minus r square is equal to 0 is the equation obtained after expanding this equation. Let us keep this as equation 1. From this equation 1, we observe that the equation 1 is a second degree equation in x, y and z, and this equation does not contain any terms of x, y, y, z and zx. So, that is another thing about this equation, and coefficients of x square, y square, z square are equal to 1. These are the three things we note from this equation. First one is this equation is a second degree equation in x, y, z, and this equation do not have any term like xy, yz and zx, and coefficients of x square, y square and z square are equal to 1. Therefore, the equation of the type x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Keep this as equation 2, having the same character as this equation 1. So, we are going to another equation which has the same character and is called the general equation of the sphere. Now, compare this equation 2 and 1, we get alpha is equal to minus u. Here this is alpha. So, minus 2 alpha x is a component present in equation 1. Similar component in equation 2 is plus 2 ux. So, alpha is equal to minus u, and similarly beta is equal to minus v. Gamma is equal to minus w, because here we got the component 2w z. In equation 1 we got minus 2 gamma z. So, gamma is equal to minus w, and here we got d. There in equation 1 we got alpha square plus beta square plus gamma square minus r square. So, this d is equal to alpha square plus beta square plus gamma square minus r square. So, these are the things we get after comparing equation 2 with equation 1. From this comparison, we get the center and radius of 2 are given by minus u, minus v, minus w. This is the center of the sphere obtained from this equation, and radius of the sphere obtained is square root of u square plus v square plus w square minus d. This is the radius of the sphere. So, from this explanation we learnt the general equation of a sphere and center of the sphere and radius of the sphere. Let us apply these concepts in the sums related to sphere. Here in example 1, we are asked to find the equation of a sphere whose center is 2, minus 3, 4 and radius is equal to square root of 51. This is the thing given. We need to find the equation of the sphere. Solution to this problem can be obtained in the following way. So, first write the equation of the sphere whose center and radius are given. The general form of the equation of the sphere is x minus alpha the whole square plus y minus beta the whole square plus z minus gamma the whole square is equal to r square. This is the general equation of a sphere whose center and radius are given. Here r is the radius, alpha, beta, gamma is the center. Now, in this problem center is 2, 3, 4 and radius is equal to square root of 51. Substitute these two things in this equation, that is alpha is equal to 2 and beta is equal to minus 3 and gamma is equal to 4, then radius r is equal to square root of 51. Substituting these values in the equation, we get the equation of the sphere as x minus 2 the whole square plus y plus 3 the whole square plus z minus 4 the whole square is equal to 51. Now, simplifying this, we will get x square plus y square plus z square minus 4x plus 6y minus 8z minus 22 is equal to 0 is the equation obtained after simplifying this equation. This is the equation of the required sphere. This is the equation of the required sphere. Now example 2. In this example, we are asked to find the equation of a sphere passing through the origin and making intercept A, B, C with the axis respectively. So that is the thing asked in this problem. Solution to this problem can be obtained in the following way. Let the equation of the sphere be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0 is the equation of the sphere. General form of equation of a sphere. Keep this as equation 1. According to the problem, the sphere passes through the origin. The coordinate of that origin is 0, 0, 0. And if the sphere passes through the origin, then d value will become 0. Now, the sphere also cut the axis at A, B, C. A, B, C. In pictorially, we can represent that sphere like this. So, O is the origin. In x-axis, the sphere cuts at A. In y-axis, the sphere cuts at B. And in z-axis, the sphere cuts at C. So, pictorially you can explain, you can draw the given problem. A, B, C are the intercepts. Then OA is equal to A and OB is equal to B and OC is equal to C. Thus, the point ABC are coordinately given as, thus the points ABC are given as A, 0, 0 and 0, B, 0 and 0, 0, C. So, this is how the points A, B, C are given. Now, equation 1, that is general equation of a sphere, also passes through these 3 points. So, we will get the following equation, that is A square plus 2ua plus d is equal to 0. So, after simplification of this, we get 2u is equal to minus a, because this sphere passes through the origin. So, d is equal to 0. Then we got 2u is equal to minus a. Similarly, 2v is equal to minus b and 2w is equal to minus c. So, these are all the values we got for 2u, 2v, 2w in terms of ABC. Now, substituting these values of u, v, w in equation 1, we get x square plus y square plus z square minus ax minus by minus cz is equal to 0 is the required equation of a sphere which has the center as origin and cuts the coordinate axis at the point A, B, C. So, from this problem what we learnt is how to get the equation of a sphere when it passes through the origin and making intercepts ABC with the axis. In problem 2, we learnt how to find the equation of the sphere whose center and radius are given. So, this is how you can apply the concepts of sphere in analytical geometry. Next, tangent to plane. So, tangent to plane is the one which touches the sphere at only one point. Tangent, to get the equation of this tangent to plane, we need to go to the equation of a sphere. So, equation of the sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0 is the equation of the sphere at the point x, y, z. So, to get the equation of the tangent to the sphere at the point x, y, z. Let the equation of a straight line through the point x, y, z and having the directional cosines L, M, N be x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. So, this line having the direction cosine L, M, N and passes through the point x, y, z. So, this is the equation of a line having directional cosines L, M, N and passes through the point x, y, z1. And let the equation of the sphere be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Keep this as equation 2. So, in this discussion we are going to find the equation of a tangent plane. So, tangent to plane means a plane which touches the sphere at only one point. Now, the point of intersection of this line 1 with the given sphere are given by this expression, that is r square plus 2r into L into u plus x1 plus m into v plus y1 plus n into w plus z1 plus x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d is equal to 0 is the equation of the point of intersection of the line with the given thing. Now, since the point x, y, z is on the sphere given by equation 2, then we will get the equation of the sphere as x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d is equal to 0. So, equation of the sphere changes to this form when the point x, y, z is on the sphere. Now, equation 3 becomes, equation 3 is this one. After this point is on the sphere, that equation becomes r square plus 2r into L into u plus x1 plus m into v plus y1 plus n into w plus z1 is equal to 0. So, this is how the equation 3 changes when the point x, y, z lies on the sphere. This equation 4 has one value of r. This equation 4 has one value of r is equal to 0. That means value of r has two values. One value is 0. Since this r is the distance of the points of intersection of line with the sphere from the point x1, y1, z1, but r is obtained equal to 0. Thus, the point of intersection coincide with the point x1, y1, z1. Hence, the line represented by equation 1 becomes a tangent line of the sphere given by equation 2. So far we discussed how to get the equation, how to get the value of r and how to show the point of intersection coincides with the point x1, y1. Therefore, other point of intersection must also coincide with x1, y1, z1, for which the other root of equation must be 0. So, equation 4 has r, values of r must be equal to 0. Initially the first value of r is equal to 0, therefore line 1 becomes a tangent line of the sphere. Then the second value of r also must be equal to 0. In this case, the condition for this is given by L into u plus x1 plus m into v plus y1 plus n into w plus z1 is equal to 0. So this is the condition for which the second value of r must also equal to 0. Hence we can say that if the direction cosines of the line 1 satisfy the condition 5, then this line is a tangent line. Therefore, the tangent plane at x, y, z is the locus of such tangent lines for all values of L, M, N. So this is the thing about tangent to plane to a sphere. Now eliminating L, M, N from 1 and 5, we get the expression x minus x1 into u plus x1 plus y minus y1 into v plus y1 plus z minus z1 into w plus z1 is equal to 0. Further simplification of this gives this equation 6. Then this equation 6 becomes x x1 plus y y1 plus z z1 plus ux plus v y plus w z plus u x1 plus v y1 plus w z1 plus d is equal to 0 is the equation obtained from equation 6. So final form of this equation will be x x1 plus y y1 plus z z1 plus u into x plus x1 plus v into y plus y1 plus w into z plus z1 plus d is equal to 0 is the required equation of a tangent plane at x1, y1, z1 to the sphere x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. So from this explanation we learnt the equation of a tangent plane at a point x1, y1, z1 to the sphere represented in general form. Next, plane section of a sphere. You know, if you cut a sphere, the cross section of the sphere will be a circle. That circle will be a planar one. So that's what explained in this part, the plane section of a sphere. When a plane cut the sphere, a cross section of a sphere is obtained as circle. In this diagram, you can see the dotted line is the cross section. That dotted line denotes the circle. Now we need to prove that the cross section of the sphere cuts by a plane is a circle, and find also its radius and center. So if we prove that, then the plane section of a sphere is a circle. Let the equation of the sphere is given by this equation 1, and ax plus by plus cz plus d1 is equal to 0. Keep this as equation 2. This is the equation of a plane, and this is the equation of the sphere. In the above figure, dotted line represents the cross section of a sphere cuts off by a plane, and C be the center of the sphere, and we need to draw a perpendicular from C to the plane. That perpendicular meets the plane at C dash, join C dash to P, where P is on the surface of the sphere as the dotted line. So we got the angle C dash P is equal to 90 degree. Now in the triangle C dash P, we got C dash P is equal to square root of CP square minus C dash square. So this is the radius, and the equation 1 and 2 simultaneously give the equation of the circle. So we proved that the plane section of a sphere is a circle. So these are the concepts we discussed about the plane section of a sphere. So in this lecture we have discussed the thing about sphere, the locus of a point which moves in space such that whose distance from a fixed point in space is always same is called a sphere. Then general equation of the sphere is given as x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Then the tangent plane to the sphere is equationally given as x1 plus y1 plus z1 plus u into x plus x1 plus v into y plus y1 plus w into z plus z1 plus d is equal to 0. Then the plane section of the sphere is a circle. These are all the concepts we discussed in this lecture. After listening to this lecture, you can answer the following questions. Find the equation of the sphere on the join 2, minus 3, 1 and 3, minus 1, 2 as diameter. Find the center and radius of the sphere 2x square plus 2y square plus 2z square minus 2x plus 4y minus 6z is equal to 15. Give the equation of a tangent to plane. Thank you.